time. So this user, maybe A, wants to go to destination server 1111. Now you all have some or the other experience in networking, and maybe we have some kind of routing protocols running here. So the traffic will come here. It will maybe like take this path and reach. Now what happens if this link fails? And assume that we have maybe EIGRP or OSPF or REP or something is going on, or maybe BGP, whatever. What if this link goes down? Or maybe what if this link goes down? Or maybe if the router CPU goes very high, or maybe is down, power issue or any hardware failure. So as per your experience, guys, what will happen?
In such kind of scenario, we should have the redundancy, right? So you can see the redundant,
yeah.
So redundant path also. So the redundant path a user will follow to reach the 111.
So first thing is, what if I don't have the redundant path? What will happen?
That time the complete blockage in the outage.
Yeah, exactly. Now, what is happening is basically when the traffic is coming here, he has a control plane. Do you understand what is control plane? Yeah. Okay. Please ask, guys. It is just the first class introduction kind of class, and I just want to, introduce about the SD-WAN, and then from the next class we'll go in full-fledged. So there is something known as control plane. Control plane where the decisions are taken, like rep, POSPF, they send the hellos, they find the path and put in its routing table. So then he will say, okay, the path, if the traffic wants to go to 1111, I will go out this interface. Then when the actual packet will come, so the control plane is where the control traffic was going on, and they were making the decision to find the path. It could be even in layer 2 also, where we have STP and VTP and all things goes on. Now when the actual traffic will come, that is known as data plane, right, guys? You have to be you have to speak so that I'll understand that. So, okay, and ask questions, guys. So the data plane, it will come, and now the actual traffic is flowing like this. Earlier, only the maybe EIGRP or OSPF packets were going on, and they were finding the best path to reach any destination. Now, what if the control plane goes down? What will happen?
Communication will also get isolated in this scenario.
Wonderful, exactly. Now he will not receive the next packets, and he'll say, okay, maybe EIGRP is down on the neighbor side, and he'll flush all the entries in the routing table. So now the actual data will also not be able to flow, right, guys? Yes. Now this is one of the problem we can say in legacy network. In SDN, what they did is they separated the control plane and data plane. If you might have studied about RR, you might have seen a scenario where RR, route reflector in BGP.
Yes.
Okay. Yeah. So one of the best use of that is they do the separation of control plane and data plane. Some other router will be doing the control thing, and the data is going via the other path. So suppose in this scenario, what will happen is he is the person manageable for or responsible for control plane, and he will say if anything comes from A to this router, he should go like this. Now, even if he is down, the traffic will continue to flow like this. So there is no impact on our actual data traffic. Getting the point? Santosh, yes. Jitendra and Suresh, you have to, this is the first class. I want you to speak up and tell me what you understand or if there is any questions. So there is a big benefit if we separate the control plane and the data plane. Control plane will say, or it will decide what has to be done, what the path has to be taken. The data plane there, when it will come, it will take that actual path. Even if the control plane goes down, because it is separated, he still has that information that, okay, I have to go like this only. So it will not be impacted. The only impact will be that if we have to take another decision, that cannot be taken because this device is down. And that is the best part, one of the best part of SDN, software defined network, that we separate the control and the data plane. So we have separate controllers in SDN, which will take the decision and tell about the devices about the decision. Even if that control device is down, the data traffic will still go, which is not the case in our legacy network. The second point or other point is, suppose I want to run EIGRP or OSPF or maybe STP or something in any of the device, I will log into that device. Correct?
Correct.
And you can say GUI via GUI or CLI. You log into each device and do the configuration. Here we have a central device for maybe configuration, maybe troubleshooting, maybe monitoring. You don't have to log into each and every device to do these tasks, which we are doing in legacy networks. So central management is there, central monitoring is there. That is the other difference of SDN via our legacy network. And that is the reason we prefer to use SDN as possible, wherever possible. Now, when we use SDN in our WAN site, the solution is known as software defined WAN. When we use this solution in data center, Cisco solution is application centric infrastructure. And when we use this solution in LAN side, we call it as software defined access. Now here in our session, we'll be studying about this. So all of them will have a centralized controller, and the control and the data plane is separated. In SD-WAN, we have a few devices like vEdge, vManage, vSmart, vBond. In ACI, we have EPIC, Application Policy Infrastructure Controller, and here we have DNAC in SD. So in this session, we'll be studying about SD-WAN. All right?
Yeah, good.
Okay. Now, if I use WAN and if I use SD-WAN, what is the difference and which is better and why? And that is the reason I was asking you, have you ever worked on WAN or not? So as you said, and let me take an example. Let me take another one. You go to office, you have a laptop, you keep it on a table, a desk. Generally, then you will connect your cable with an extension port, generally, or maybe you connect the cable to a phone, and from the end back of the phone there is another cable which is going to that extension. Is that correct, guys?
Yeah.
That is what the scenario happens. From the back, if you follow this cable, generally it is going to a switch which is inside a room, and we have multiple switches, and generally we call this as a hub room. Like in one of my previous organizations, we were having 6 floors. Every floor was having a hub room. So we have a lot of people sitting in the bay, and we have multiple bays. So all the cables from the back was coming and was connected to these switches. Then there was some cables which is going from the back of the switch, and it was going to some another switch, maybe on one of the floor. From the back of that, we had some cables which was going to some layer 3 device, and from there it was going out. Now these switches are generally, and it is not like this has to be like this only always. It could be, it depends, it could vary. This is known as access switch. You might have studied about Cisco 3-tier architecture also, and generally this is the case. This is known as aggregation switch, or it used to be called as distribution also, distribution layer. And then it goes to this router or a layer 3 switch, which is known as core layer or core device. Right, Santosh, Suresh, Jitendra?
Yes.
From here, it is now here I'm sitting here and I'm working in company ABC, and I want to check my email. So I'll open my email, and my email is, say, for example, abc@abc.com, whatever. So I'm trying to go to a mail server, abc.com. That mail server of my company is kept in my data center. I want to access this. So from my branch, via some ISP, I will have this connectivity. And I can reach it and I get my emails and all the traffic. I'll see that. So your PC is going to some LAN, and then it is going via aggregation, and then some routers. It is going maybe via MPLS. Generally, it is MPLS, or maybe via internet towards your data center to access your servers. That is normal WAN situation. Have you seen this situation in your production?
Yes, yes.
Yes.
It is a mix of yes and no, because multiple times, when I was a level engineer, I didn't have this kind of knowledge that what actually is going on at the back end. I was just configured, interested in that my PC and that cable. I was not aware of all these things initially. So it is possible that you have this knowledge, you have seen this. It is possible that you didn't get a chance to see all these things. So later on, I used to follow the cables and go to hub rooms and see how the connectivity is, how the traffic is flowing. So you might have seen this, you might not have, but it should be something similar everywhere. Now here, when it is going to my data center, generally it is an MPLS connectivity. The ISP is providing me the MPLS. What if this router goes down? Or maybe what if this link goes down? Or maybe what if there is some issue on the ISP side? Suppose you are a LAN engineer, as you said, you're working, and user will come to you and you will say, and he will say, no, I'm not able to reach a particular server. Or maybe if I'm able to reach, there is a lot of latency. How do you troubleshoot? Or did you get a chance to troubleshoot that kind of scenario?
Yeah, yeah.
Yeah,
For
yeah.
that,
So tell me one of the maybe some steps.
in this
Yes.
scenario, we
Yeah.
log to the router like core A3 device, and
Hmm.
like in my scenario,
Yeah.
every branch has two ISPs. Like either it is a BGP, and secondary would be like a VPN connectivity through IPsec. So I'll check the BGP status. If it is up, then we'll ping the peer IP and find the latency related things. If it is up, then otherwise, if it is down, then we'll come to know that there is some issues in.
Yeah. So something similar we do. And generally what happens is we have more than one connectivity, maybe to the same ISP, or maybe to internet, or maybe we have a backup ISP. As a best practice, what I have seen is we have a router. It is connected to primary ISP. If it goes down, we have a secondary ISP for MPLS. Similarly, we have one internet connection. If it goes down, I have a backup internet connection. That is always a scenario I have seen till now. If one goes down, we have the backup. And it is active passive scenario. If this goes down, then only I will use this. It is very rare that I have seen it is active. If this goes down, I already have another link where the traffic can go. If I want both of them as active, I need to have additional configuration, and the complexity will also increase. So majority of the cases, we don't find this solution of this active toward MPLS or maybe towards internet, right? So here, if the MPLS router or the ISP router or my end router link performance goes down, it is up and working, but its performance is down. It will not shift to the another device, another link, right? It is not going to do anything. Users will complain. Maybe the bandwidth is choked, maybe some physical layer issue, some CRC errors, but the performance is down. So I cannot avoid this. I cannot automate this. Okay, if this is down, fail over to the other one. It is not possible. In legacy networks, we cannot solve it. It is a manual process. It is not an automatic process. You will log into this router. You will troubleshoot. You will find the problem. Maybe you will say everything is fine from my end. You will raise a ticket with ISP. Now they will again take time to find out the reason and then resolve it. Till that time, this user will face this latency. Right, guys? Yes.
Right.
Yeah. So that's what is happening. In SD-WAN, it will not happen like this. The routers are intelligent. You know. Now, suppose I'm using SD-WAN instead of the physical MPLS and internet. I was not using SD-WAN earlier. Now I am using SD-WAN and the link performance goes down. Again, could be anything. Maybe the CPU went high on the routers, maybe some physical CLC, reasons. But the users are complaining that I'm facing slowness. So in SD-WAN, router will take action automatically. One of the action could be like it will fail over to the other link automatically. And within seconds, this will say, now I'm working. It is working fine. You don't have to come. You don't have to call an engineer. You don't have to log in, troubleshoot, maybe contact ISP. Nothing is required. And that is one of the reason SD-WAN is growing very fast, and almost every company is going for it.
Sanjay, actually, one of my question on this, like in the current scenario, we have the telco or kind of fiber connectivity, you can say between one branch to second branch. So what is the scenario in the SD-WAN? Like it is the mediator connectivity is also like using the telco network, or how, I mean the physical setup, how they will connect, right?
What happens is, guys, all of you, do you understand the difference between underlay and overlay? Yes or no? Just be honest. We have to discuss and we'll find out. Yeah, that's better. If you say no, that is good for me, so that I'll go in that kind of depth wherever required. Santosh, please speak. Take participate. So what happens is, let me get another page.
I don't know that overlay underlay.
Okay, fine. But speak up, then only I will understand. That someone doesn't know, and I'll explain. Suppose I have a router. I'll start with a simple one, and this is your company, site 1. This is your another company, site 2, and this is internet, ISP. Can you have a EIGRP neighborship between your two routers, R1 or and R2? Yes or no? I
No.
want no, exactly. It is no. I have a PC here, which is maybe 10.1.1.1/24 as an example, and a PC here is 10.1.1.2. Now I want that my local information should go to my another data center, that site, and I want to have an direct connectivity so that I can have EIGRP neighborship and I can distribute my routes and I can have the reachability directly. I want it to be as if the router 1 is directly connected to R2. If the scenario is like this, I cannot have any RIP, EIGRP, OSPF working on this one, because the requirement for IGP is that they have to be directly connected. So what I can do to resolve it, I can use a tunnel between them. You might have seen GRE tunnel or maybe interface logical tunnel. Have you configured that anytime?
We configured, from my experience, the IPsec.
Yeah, IPsec is okay, fine. So what happens is I will create a tunnel. I'll say the tunnel source is this interface of R1 and destination is this. Similarly on R2, the tunnel destination is R1 and my own is a source interface. So sure, Santosh. Santosh has a meeting, office meeting. So what I was saying is, if I create a tunnel, physically the path is via R1 to ISP router to R2. But logically, R1 will say that it is directly connected to me via that tunnel. So physical devices are known as underlay. Physically, cables are there, the routers, switches, the devices are there. That is underlay. Overlay is which is appeared, virtualized. Logically, it is there. That is shown to the maybe client. For client, R1 is directly connected to R2. But it cannot go in air to reach R2. It has to use that physical path only. Getting the point, Chitender?
Yeah, got it.
So we create a logical interface, logical tunnel, and on that tunnel, I can have EIGRP neighborship. If time permits, I'll show you, on our software also how to create that. And they will have a neighborship. of hierarchy or OSPF, and then it will appear as this is like without an ISP in between.
Okay.
So similarly, what happens is if I have my this is my branch, this is my another branch, this is my another branch. So the question was how the SD-WAN is physically. It will be going to one of the ISP, maybe via MPLS. Let us say the 3 branches are connected via MPLS to my data center. So underlay, it is using MPLS or internet or 4G, LTE, whatever. But in SD-WAN, they will use an overlay. The overlay will say, I am connected like this directly. So underlay physical path is this. But SD-WAN will create a logical tunnel kind of thing, which I'll explain to you later in detail. Jitendra,
Yeah. Okay.
does that answer your question?
Yeah. Yeah.
And we'll come to these things, a lot of scenarios in detail shortly in the future in our classes and upcoming classes.
Okay. Thank you.
All right. So one of the thing what I was discussing is, yes, when we are using a legacy network, if there is an issue, it will be delayed if the performance is degraded or if the network engineer has to come into picture. So I'll definitely prefer to have SD-WAN where the routers are intelligent and automatically it will fail over to the better link. Correct? Okay.
Okay.
Okay. Now, what happens? One of the other reason for going to SD-WAN is generally what happens is all our applications are sitting in our data center, and we have a lot of branches connected to that. All of the branches will reach to the data center via this MPLS circuit. And earlier they were not using internet, but now they have started using internet also, because internet was not much reliable earlier. There were a lot of losses, slowness was there, the services were not guaranteed. If internet connectivity, their ISP is providing me internet and they are saying it is 100 Mbps connection, for example, it is not 100 Mbps 24/7. So SLA was not there. But it was not the case with MPLS, so we used to go with MPLS only. But then internet was cheap and MPLS is very costly. Because internet is also getting reliable day by day nowadays, we are going to internet also as of now. Now, in this scenario, I will use MPLS link also, I will use internet link also. And maybe, I have a requirement now to use Office 365. You might have seen this. Have you seen in your production that we are moving to Office 365 nowadays?
Yeah, I saw the TCS Office 365 on the mail.
Yeah, it is happening with almost every organization. It happened with mine also. So now we are moving towards Office 365 and we are using Dropbox, or we are using a lot of cloud applications. The cloud applications might be hosted in Azure cloud, some are in AWS cloud, Google cloud, GCP, Alibaba. So what I have to do is I have to build the MPLS from the branches to the cloud so that I can access those services. But again, the problem is a lot of money has to be paid for this dedicated MPLS circuit. I can save this cost by using SD-WAN solution. There is no need to buy this MPLS circuits. Why? Because, the low cost internet is also reliable now. But the problem is we cannot guarantee that the internet is all the time up and there is no loss. It is not possible. So I'll go to SD-WAN. Suppose, or let me use the same scenario. Uh, the branch router, the end router will check the performance of the link, and it is going to maybe say that cloud AWS, and if this one of the link goes down, he will automatically move to the another link. So there are few reasons we are moving towards SD-WAN, and you will see everywhere we'll have SD-WAN, not the legacy WAN, sooner or later. So the operations are complex if we are using legacy WAN. The operation is comparatively very simple comparatively with SD-WAN. The cost was very high in legacy networks. The cost is comparatively very less with SD-WAN. One of the other reason to move to SD-WAN is, scalability. Jitinder, what is scalability?
Technical term I can't explain you now. I mean,
Fine. Scalability means if I want to grow, if I want to
okay.
add more, devices, or I want to grow or more sites, like on a switch, if I want to connect more PCs, so I want to
Mhm.
scale. With legacy networks, the scalability is limited. Here it is unlimited. You want more sites, just connect it, and it will start
No,
working.
one more question. I am not sure about the GRI. So like MPLS or kind of lease line, like suppose if we are going to extension our network, so then we can increase the internet bandwidth capacity or kind of that. So how we manage it to the, I mean, the SD-WAN, like, so got my point. So is there any limitation for SD-WAN, or we are okay to any kind of traffics or like 50 Mbps,
No,
100
no, it
Mbps?
depends. See, logically it will use a tunnel
Mhm,
overlay, but
mhm.
physically it is going to the from the underlay only. So if the link is 1 Mbps, I cannot send the traffic of 2 Mbps. That will always be there.
So
But there
you
are
mean
so
again, my question is like for SD-WAN we still required a kind of service provider, right? Like those are
yes,
supporting the SD-WAN, so we need
no,
to go.
no. SD-WAN is not on the service provider side. It is on me. I will
No, no,
configure it.
that's okay. But like suppose one of my branch is Singapore. My
Mhm,
second branch is, you can say, the Malaysia. So
mhm.
between the Singapore Malaysia, I will configure the GRI tunnel or kind of that, right? But how we control the traffic? Like suppose my capacity is currently the 20 Mbps, and the traffic will be my organization will grow. Then I required the 50 Mbps or 60 Mbps. Sorry, might be my question is not related to the
No,
SD-WAN or kind of that, but this things is coming in my mind.
yeah, that is fine, Jitendra. One thing is, when I have two sites, two branches, or one branch is connecting to other branch, or one
Mm,
branch is connected to data center, or maybe to cloud, the connectivity has to be there.
mm.
Either you use dark fiber lease lines, or you use any service
Yes.
provider, or you use MPLS or internet. That has to be there. SD-WAN is independent of the transport media. You use any kind of this one transport, but transport has to be there. That is underlay. Let
Okay.
me
So you
see
mean
if I have any diagram. Uh, yeah, one of the diagram which I wanted to show later, but let me get it right now. Uh, See, like this. This is your data center. This is your campus. This is your branch. This is your small office, home office routers. This is cloud. They are connected to each other, maybe via 4G LTE, maybe via MPLS, maybe via internet. That is okay, but there has to be a connectivity. Now it is independent of the transport medium you are using for the reachability. That is anything. That could be anything. But
mm.
increasing the bandwidth is a separate thing.
No, that's okay. But
Yeah.
like we have some communication media between this, right?
Yes,
So
yes,
so so like we are using the Vodafone, so we can reach the Vodafone, right?
yes.
So I mean, the setup I need to understand. Okay, now it's okay. Now, at least we have some communication media between our branch or centralized uh, core network, right?
Yes, yes.
Okay. So
Okay,
how we are managing, that is the different thing, right?
exactly. Yeah,
Like
exactly.
instead of physical router, we are using like vManage or V Smart kind of. That is a different thing. But at least we have some communication media similar to the MPLS or the internet, right?
Yes, we have to have, and you it will be more clear to use shortly, slowly, day by day,
Okay,
when we
okay.
will understand this, the configuration, the different topologies, and all those things.
Okay.
And
Got
I
it.
appreciate that you're asking questions, Jitendra. I want that throughout our classes. Ask questions. Don't hesitate. It will give an
Okay.
idea on what how in depth I have to go in a particular topic.
Okay. Thank you.
Okay. Now, what I was saying is that I will prefer to use SD-WAN. That was I was discussing. Uh, in this initially, let me get the same diagram. So if you see, we discussed about the control plane and data plane few minutes back. Now we have management plane also. We have orchestration plane also, and we'll be doing this again later on. Now this V bond is known as orchestrator, and basically it has two main functions. First, discover the elements, the control elements, and second, notify the edges about their public IP if they are behind NAT. Uh, V bond, they have not shown in this diagram clearly, but that is okay. So suppose you have this data center, you have this maybe campus or any branch, and these are your edge routers. Edge router can be a V edge router or it can be a C edge router. I'll come to that. Uh, so you connect this router, he will connect the V bond first. It is like vWAN will say, I allow you, you know, you are onboarded or you are not onboarded. It is authenticating the edge devices. Of course, we will have a method of using certificates and we have to whitelist that initially. Authentication is done by the vBond for the first time when a device comes into SD-WAN. Okay, Jitendra?
Okay.
Then we have the management plane. The device we call it as vManage. It is a virtual appliance and we can log in via GUI, CLI, via API. It is the place where you do the configuration of all the devices, everything. All the configuration is done on the vManage. You provision, you do the provisioning. Like I have to do software upgrades, I do it via vManage. It is the central place where you can use it for troubleshooting. You can use it for monitoring. Then we have vSmart. vSmart is the control plane. It will distribute the control plane information to our WAN edge devices. So every device has a separate work. vManage, vBond, and vSmart. These are the control devices. The traffic, now suppose these are my three devices initially, and everything is set up. The traffic from maybe this data center might go directly if there is a path. It doesn't have to go to ISP and come back, or maybe to some other way and come back. The data plane is different, the control plane is different. Getting my point?
Yes.
Okay. This, if we have the devices, it could be V edge router or it could be C edge router. V stands for Viptela, C stands for Cisco. V edge, Viptela edge, because actually it was created by Viptela SD-WAN, and that is acquired by Cisco. Then Cisco came up with its own devices, so it is known as C edge devices. So you can see V edge and C edge both. It could be again physical, it could be again virtual. If we talk about uh, V edge, router and device, we can have physical, and in physical we have V edge 100, we have V edge 1000, we have V edge 2000 series, we have V edge 5000 series. And if I talk about virtual, you understand virtual, right? What is virtual?
Yeah. You can say it's not a
Program.
physical device.
Yeah.
You kind of manage
Yeah.
the virtual machine or.
Exactly. And software is there on a hardware,
Yes.
not the actual hardware appliance.
Yes, yes. Similar function using some VM machine or kind of.
Exactly. So VH can come in physical hardwares also, or you can use virtual also. Similarly, for C Edge, Cisco Edge, we have ISR 1100, we have ISR 4000 series, we have ISR, we have ASR 1000 series, we have ASR 8000, I think 8000 series. So these are all physical.
So one more question might like ISR or ASR, we can also use our normal function, right? Or
Yes,
these are,
yes, but they have this image of this one.
okay. Okay. So
SD-WAN.
we need, if we want to use the SD-WAN, then we need to upgrade the required image on that router, right?
Yeah, these comes with this image. I'll show you.
Okay.
And for virtual, we have CSR 1000V. These are virtual devices.
Okay.
So we have physical also, we have virtual also. Now, I have not come up till, but let me show you the lab. I hope you have gone through the syllabus already. Is it?
Yeah, we watched.
Okay. So you will be given access to this labs also. So this is the topology we'll be using. We have vManage, vSmart, vBond. Then we have this New York headquarter. We have different sites connected via internet and connected via MPLS. So we'll understand how to configure, what all the things we have to take care, and how that path will be there. What if one path goes down? How automatically it will take the another path. Okay, Jinder?
Yeah, sure.
Okay, so we'll be starting from the basics again, from the scratch towards the very complex thing of SD-WAN. And again, Jitendra, small request will be for you, for everyone. Suresh will also join shortly, he said. Uh, don't put yourself on mute. Ask questions. Do the labs along with me. When I show you the lab, then you have enough time to do that. Do that and ask questions. Don't just listen and like many students I have seen did that. Just listen and go. Then it will not be. Will not enjoy the class. Then we have to discuss. A lot of doubts comes.
So one more thing, Sanjay, as I checked this, one of my friends, so he told me kind of we use the certification CA kind of certificate.
Yes.
So we will also use SAM in our labs because
we have to use. Otherwise, we cannot do this lab. We have to use that.
Yeah, because some sorry, but some other tutor they don't involve kind of the CA server or
no. We have the CA server here. The last one, server CA.
Okay.
We have to do that. That is the first lab actually. Apart from giving the IP addresses, that is the first thing we have to do, the certification installation.
Okay.
So I'll be covering everything, almost everything here. Today, I just wanted to know the level of whoever is joining, and many people I have seen, they didn't have an experience in working with WAN, so it is very difficult for them to understand what actually is happening, why we are going for SD-WAN.
Yeah, exactly.
And that happens. Everybody doesn't get a chance in every technology to work in every technology. So it was a very short session today, just as an introduction, and do let me know if there is any doubt, anything.